Yesterday we started our unit on trigonometry, and we started by learning what the tangent ratio was. Today we're going to continue with the two other ratios, which are our sine and cosine ratios. Your essential question is, how do I use the trigonometric ratios to find missing measures? My learning intention. I'm learning to find missing measures using the trigonometric ratios. So you've got one word-em-up question with 4 pieces. It says, to find the tangent of y, the tangent of z, the measure of angle y, and the measure of angle z. As we're looking at this right triangle, we notice that we are missing part of it. We're missing a length. How do we find that missing length? If you said Pythagorean's theorem, you would be correct. So I've got the hypotenuse and the leg. That means that I will be using subtraction. xz quantity squared will be equal to 17 squared minus 8 squared. The opposite of squaring is square rooting. So it will be the square root of 17 squared minus 8 squared. Close it and square it. Or square root it. I've got 15. So this length here is 15. So if you're looking at it, 8, 15, and 17 do not have any common factors. So once we find those fractions, they will be simplified. So the tangent of y, if y is up here, opposite is 15, adjacent is 8. Remember, we use that tangent inverse button. And it will be an approximation. So I'm going to go second tangent, and then it is 15 divided by 8. Close it off, and I get 61.9. And that will be degrees. Okay, for tangent of z. Remember, on the tangents, they will be reciprocals. So this becomes 8 over 15. And there are 2 different ways I can find that measure of z. I know that the measure of z and y have to add up to 90 degrees because this one is 90. 180 minus 90 leaves me with 90. So I could take 90 degrees minus 61.9 degrees. Or, once again, I can use that second tangent, 8 divided by 15, close it, and I get 28.1. And that is in degrees. So tangent is your opposite length over your adjacent length. Which side is opposite depends on which angle you're at. And we're going to look at the other 2 trigonometric ratios, which are our sine and our cosine. Okay, sine is the opposite length over the hypotenuse. Cosine is the adjacent length over the hypotenuse length. So we're going to find the missing measures. The first thing we have to do is to find that third side. It's a right triangle. Whose theorem do we use? If you said Pythagorean, you would be correct. So I'm looking for the hypotenuse. I know the 2 legs, so I'll be adding. Km squared is equal to 63 squared plus 16 squared. I'm going to square root both sides. And I end up with 65. Now, you always need to stop and think and make sure that it makes sense. The hypotenuse is my longest side. I've got 16, 63, 65. It does make sense. It is the longest side. So now, let's look for the sine of the different angles. Remember, the sine of k, here's k, is opposite over the hypotenuse. The opposite is 16. The hypotenuse is 65. Can it be simplified? I don't know. I don't see anything that should go into both of them. But if I'm making sure, I'll take 16 divided by 65. I'll hit my math button. I'll hit enter and enter again, and it's still 16 over 65. So that is simplified. For the measure of angle K, this time, instead of tangent inverse, I'll use the sine inverse of 16 over 65. So second, sine 16 divided by 65. Close it off, and I get 14.25, which is about 14.3. degrees. Okay, where the tangents were reciprocals, are the sines going to be reciprocals? No, because we're not using the same sides. The sine of m, if I'm down here, my sine is 63. My opposite is 63. My hypotenuse is 65. Now we know that there are only two numbers apart. Neither one of them is even, so there will be no common factors. For the measure, there's two ways I can do it. I can take 90 degrees minus 14.3 degrees, or sine inverse, second sine. 63 divided by 65, close it off, and I get 75.7. Okay, what about the cosine? Looking up here, cosine is your adjacent over your hypotenuse. So if I'm looking at cosine of x, my adjacent is 63. And my hypotenuse is 65. If I come down to the cosine of m, my adjacent is 16. And my hypotenuse is 65. Okay, now take a minute and look at what happens. The sine of one angle is the cosine of the other. The cosine of this angle is the sine of the other. Do I need to look at my angle measures again? If I did second cosine 63 divided by 65, would I get a different answer? Nope, I still got the 14.3. So either way you do it, you will get that angle measure by using your inverse buttons. Okay, on your own, find all the missing measures. It says find the hypotenuse, but you're actually looking for a leg. Find the sine of x, cosine of x, tangent of x, and all the missing measures. So, if we're looking at this, what do we do first to find that missing side? We'll use Pythagorean's theorem. We know the hypotenuse. That means we have to subtract. DE squared is equal to 20 squared minus 16 squared. Now, as I'm looking at these numbers, I realize that they're even. All of them are even. Those two are even. So I know that I will have to simplify my fractions. Square root both sides. Second, x squared, 20 squared minus 16 squared, and I end up with 12. Okay, now I'm ready to find cosine, sine, cosine, and tangent, and then find the two missing angle measures. So this is my angle theta. The sine of theta, the opposite over the hypotenuse, 12 over 20. Both of those have a factor of 4. 12 divided by 4 is 3. 20 divided by 4 is 5. So that is the fraction 3 over 5. Cosine of theta. Adjacent is 16. Hypotenuse is 20. This time they both have a factor of 4 again. 16 divided by 4 is 4. 20 divided by 4 is 5. And finally, the tangent, which is the opposite over adjacent. Tangent of angle theta is 12 over 16. Factor of 4, 12 divided by 4 is 3. 16 divided by 4 is 4. So that we've got in the ratio 3 to 5, 4 to 5, and 3 to 4. So, how do I find the measure of angle theta? Do I want to use sine, cosine, or tangent? Does not matter. Let's use cosine, because we haven't used cosine inverse. This will be 4 over 5. Second, cosine. 4 divided by 5, close it off, and I get about 36.9. Okay, to find the last one, I can do cosine inverse again and use the 12 over 20. And get 53.1. If you notice, I did not simplify the fraction. I didn't need to. I wasn't looking for the fraction itself, but for that last angle measure. If I wanted to, I could have always subtracted. If I would have wanted to, I could have done 90 degrees minus 36.9 degrees, and that would have given me 53.1 degree also. So take a minute and look at it. Go back through and do the problem again if you're still struggling. Even if you repeat the same problem, it will help you. Okay. What is the relationship between the sine of theta and the sine of d? Well, there really isn't any between them because they both use different sides. But the sine of angle theta and the cosine of angle D are the same fraction. So the cosine of one and the sine of the other are the same fraction. So we're looking at, we've got to be able to remember these somehow. So we've got an acronym that's called SOHCAHTOA. So is the opposite over the hypotenuse. Ka is the adjacent over the hypotenuse. Toa is your opposite over your adjacent. Now, if you are looking at it online, this is a clickable link to the SOHCAHTOA song, which is also posted in our Google Classroom. So, how do you know you're successful? You know you're successful when you can find missing measures using the correct trigonometric ratio. So this is tangent, which is your opposite over your adjacent. Sine, which is your opposite over your hypotenuse. And cosine, which is your adjacent over your hypotenuse. So we will continue to practice using these trigonometric ratios.